I found the time to make some videos for some of these checks for understandings if you guys needed some help with things. So hopefully I can be there, even though I'm not there. If I make mistakes on this, I'm gonna apologize. I didn't actually plan any of these ahead of time. I'm just doing my best to get some resources available for you guys, so you guys can see how to solve some of these things. So I'm gonna start solving this one now. In the sake of, I have about 15 of these things, maybe less than that, maybe like 10 of these things to do. So I'm gonna try to get them input into this as quickly as possible. So here we go. So guys, here we go. This right here is Algebra 1. This is Investigation, Algebra 1, 5. Oh, sorry, not 5. I'm gonna erase that. 8.9.1.1. So it's not Algebra 1. Excuse me. This is just 8.9.1.1, the first investigation we did while I was away. So number 1, it says right here we need to write an equation that could be best used to determine the amount of water in Craig's pool at any time while he's putting water into the pool. Let X represent the time in minutes spent filling the pool, and Y represent the total gallons of water in the pool. So, reading this situation, Craig and Kelly have a swimming pool that holds 1,175 gallons of water. Craig's pool is empty, and Kelly's pool has 200 gallons of water. Craig and Kelly will fill their swimming pools. Craig's pool fills at a rate of 5.5 gallons per minute. Kelly's pool fills at a rate of 3 gallons per minute. So I'm going to go ahead and just look at this one. This one's only asking me for Craig's pool. So right here, Craig's pool's empty. So we know that we don't have anything additional to add on to it, but we know that his rate fills at a rate of 5.5 gallons per minute. Let's look at this. So X represents the time in minutes. So good, we're already in the correct units. So we're going to go ahead and write 5.5 times X, because if it fills for 1 minute, you have 5.5 gallons. If it fills for 2 minutes, you have 11 gallons. If it fills for 3 minutes, you have 16.5 gallons. Obviously, it's going to take a really long time to fill this up, so we're just going to go ahead and leave it like this, okay? So our equation, our linear function, is y is equal to 5.5x. I'm just going to add a little something to this. Our domain is going to be technically from 0 is less than x, or I guess less than or equal to, because you can be at 0 seconds and have 0 gallons. Technically, you could fill it up forever, but we really only care about until it's full. So we're going to leave that blank for right now, but how you would figure that one out is you'd figure out how long it takes to fill up the pool, and then that'd be your top domain. So number 1 was that. Number 2, write an equation for Kelly's swimming pool. So once again, Y represent the total gallons in the pool. So Y is equal to, well, look at hers. Hers already has 200 gallons in it. No matter if she's filled up for 3 minutes, it started off with 200 gallons. If you filled up for an hour, it still always started with 200. So our rate in this case is 3 gallons per minute. So the units are correct. So we have 3x plus 200. Because 200 stands for when she started filling in the pool. So our domain for this one is going to be, again, from 0 is less than x, which is less than whatever our top domain is here. So however long it takes to fill the entire pool is our top domain. Let's look at our range here. I know we didn't do range for the other one, but I'm going to go ahead and talk about it anyway. Our range here, well, if x is equal to 0, which is our lower domain, 3 times 0 is 0, plus 200 is 200 is our lowest possible value in this case, because you can't fill it up for negative seconds. And at 0 seconds, it already has 200 gallons. Is less than y, which is less than, well, the maximum, sorry, less than or equal to, well, our maximum, our pool holds is 1,175 gallons. So that's our range on that one. So how long will it take Craig to fill his pool? So let's go ahead and solve that. Our y is to fill the pool. So our value for filling the pool is 1,175 is equal to 5.5x. Now to get x by itself, since this is multiplication, I'm going to divide both sides by 5.5. And I would have, well, let's go ahead and use my calculator. 1,175 divided by 5.5 is equal to 213.67 repeating. Oh, sorry, not 67. 63 repeating. Which this one's kind of a weird one to know, but on your guys' calculators, you have a button that says like 2. It looks like this. It has like an arrow, and then it'll say frac. That means 2 fraction. So make sure you guys, you need help with that. You'd put second answer, 2 fraction, and then this would be your fraction of 2350 over 11, or 213, and I believe that is going to be 6, 11, 7 and 7/11. Well, if someone came and told me that it took me 213 minutes and 7/11 minutes to fill the pool up, I'd be like, bro, like, why are you talking to me about 7/11 of a minute? So why don't we give it to them in seconds? Well, 7/11 of a second is 37.8 seconds. So I would just estimate this to be, the answer to this one would be 213 minutes and 38 seconds. That's a lot more meaningful in terms of our answer, okay? All right, let's look how long it takes. Oh, and then, sorry, once again, this now becomes our upper domain for this one. Where this is a case you can use a decimal because it's more mathy. This is more math-like. This is more of an answer to tell a person. So you want to make sure it makes sense. Number 4, how long would it take for Kelly to fill her pool? So we're going to take the same equation, 1,175, because that's how much capacity the pool has, is equal to 3x plus 200. Get x by itself, so subtract 200 from both sides. We'd have 975 is equal to 3x. Divide both sides by 3. And you'd get x is equal to 975 divided by 3 equals 325. So it would take 325 minutes, which now makes this the upper domain of that function. So that is how long it takes to fill up this pool. Next, for number 5, it says if you were to graph your 2 equations on a coordinate plane, they would intersect. What would this point represent? Let's go ahead and graph these 2 functions. I'm going to go ahead and put it right here. Number 1, I'm just going to draw like an estimation, right? So this one starts at 0 and it goes up at 5.5. This one starts at 200 and it goes up at 3 because it's a less slope, which means the line is going to be less steep. So what it's asking you, what does that blue point mean? Well, that blue point is when they, oops, too thick. Jeez, I am not very good at this yet. There we go. They have the same amount of water in the pool. Okay. All right. I'm going to stop this one. I know it's pretty short and sweet, so I hope you guys were able to get help for that. Bye.